I'm jumping in here assuming that you read the notes and or this section in the book, section 4.3, concerning properties of logarithms. We'll just do a couple of examples here to see how those work. There are two directions we can go using these properties. One of them is I'm starting with a logarithm of one expression, and my goal is to expand it so that I have a number of simpler logarithms of simpler expressions. So we'll do that one first. First thing I'm going to notice is that there's a quotient there, x to the 7th divided by 100y cubed. So the first thing I'm going to do is use the rule that says I can split up a logarithm of a quotient by taking the log of the top and subtracting the log of the bottom. So that's 100y cubed. The next thing I'm going to notice is that 100y cubed, that's a product. That's two things multiplied together. To do the logarithm of a product, I'm going to do the logarithm of each one separately and then add, and I'm going to do it carefully because I have that negative out in front. For right now, that log of x to the 7th is just along for the ride. We'll subtract the log of the first thing, which is 100, plus the log of the second thing, 1 cubed. So now I've broken that product apart into its two component pieces. Now, we had another rule that says if I have the logarithm of something raised to a power, I can take that power off and bring it down in front and multiply. So now I have 7 times the log of x and then continuing minus log of 100. I'll go ahead and distribute that negative sign through there, minus the log of y cubed. Notice here we're using common logarithms. That's log, just log, with no base specified. Common logarithm is base 10. So that middle term says log base 10 of 100. Well, 100 is 10 squared. I can actually do that one. So now I have still 7 times log of x. But instead of minus log of 100, log base 10 of 100, there's just 2. That's much more simplified. And then my next term, also negative, that's log of y to the 3rd power. Well, we saw before, and it applies here too. I can take that power, bring it down in front, and multiply. 3 times log of y. At this point, that expression is as simplified as we can get it. Log of x, log of y, and 2. So we're done. The other choice is I have an expression that's already kind of in pieces, and I'd like to put it together as one logarithm of one single expression, like my second example here. This one is a natural logarithm, so that's a logarithm base e. E, you might remember, is a number. It's between 2 and 3, 2.718, something. It's kind of like pi. It never repeats. It never ends. But you don't necessarily have to remember any of that. Just recognize that natural log, ln, means log base b. Just to be clear, that is lowercase ln and not uppercase in. It's ln as in natural logarithm. I'd like to put this logarithm in together so that I have one single natural log of one single expression. I see pluses and minuses both in there, so I'm going to have multiplication and division. I'll have a numerator and a denominator. The first thing I'm going to do is I have 5 times natural log of a. The natural log of 18 is just going to be along for the ride for a minute while we deal with this. Going the other direction, if I had an exponent, I could bring it down front and turn it into multiplication. Going this direction, if I have a number out in front, I can put it up as an exponent. So I'm going to write plus natural log of a to the 5th power. Same thing with the next term, minus natural log of b to the, and we'll move that exponent up there, b to the 3rd. The first two expressions are positive. Pretty much anything that's positive is going to go in the numerator. Anything that's negative is going to go in the denominator. So I'm ready to write one single natural log, not like that. Natural log of my 18 will be on top, a to the 5th, also on top, b to the 3rd, that's negative, so it's going to go in the denominator. One single log of one expression.